Hi, good evening, everyone. So, welcome to the live session for the course Industrial Wastewater Treatment. And I'm Niketa. I'm a PhD student at IIT Madras, and I'm the TA for this course. So, the live sessions are meant to be, it's like a live class where you get to ask your doubts or questions if you have any, and it's going to be like an interactive session. And what we'll do is we'll just look at some brief overview of some topics that you've already seen in this week's lectures. And yeah, so that's what we'll be doing this week. So before we start, do you have any questions from this week's lectures or from the previous week's lectures? No questions? People are still joining. Okay, so since you don't have any questions, so we'll start with the class. So this week you must have seen about two industries. First one is tanning industry, and second one is the paper and pulp industry. All right. So can someone tell me what is the tanning industry? What do we get from a tanning industry? What is the final product? So what is the purpose for having a tanning industry? Like, um, what do we do and what happens in the tanning industry? What is the final product that we get? It's okay if you don't want to speak up, you can even type your answers in the chat box. What is a tanning industry? Okay, so tanning industry is used for manufacturing leather. So leather is manufactured by processing raw animal hide. So that is the raw material for this industry. So the tanning industry transforms animal hide into leather. So leather is the final product, and leather is highly stable. It is also prone to rapid biodegradation, and that is the advantage of this process. Like, we get something which is stable instead of raw animal hide, which is prone to degradation, quick degradation, that is. So the wastewater that comes from tanning industries or tanneries is usually high in so it has high BOD. So what is BOD here? What is the meaning of BOD? Or at least tell me what BOD stands for. So BOD stands for biochemical oxygen demand, and that means the amount of oxygen that is required for biological degradation of organics present in the water or wastewater. And the tanning industry wastewater has high BOD, and it also has high amount of dissolved salts. So the dissolved salts are mainly chromium salts, like chromium, trivalent chromium or hexavalent chromium. So of these, the hexavalent chromium is known to be more toxic. So that is why the wastewater that is coming from tanning industries need to be treated properly. All the chromium needs to be removed, because otherwise it can be dangerous for everyone. And the leather manufacturing process has 3 steps. First step is preparation of the hides. And the second step is the tanning process. The third step is finishing. So let's look at the first one. First one is preparation. So in preparation, that's the first step. So here we get the raw hide or the raw animal skin. So the raw animal skin will have sometimes flesh, sometimes it will have some blood also, and there will also be some hair. So the raw hide is first treated with salt to prevent bacterial decomposition. So since the animal is dead, so the bacteria will now start to decompose the flesh and then the skin itself. So to prevent that, we add a lot of salt. So that is the first step. The second step is rehydration. So rehydration, also called as soaking. So in the first step, after applying the salt, all the moisture will be drawn out. So that will make the hide very dry, and also we cannot use it for further processing. So that is why we need to make sure there is moisture inside, and that's why we have to rehydrate the skin. The third step is liming. So liming is adding lime and sodium sulfide. So this is done to loosen the hair follicles. Like I said previously, animal skin could have some hair also. So that needs to be removed before further processing, and for that we have to add lime. So if we add lime, then the hair follicles will be coming out easily. And it also removes flesh and some non-collagen proteins which are stuck to the skin. And the next step is deliming. So deliming means in the previous step, since the lime is added, the pH will be quite high. So we have to remove all that excess lime. So to do that, we perform deliming. The next step is baiting. So baiting is done by just like physically beating on the skin to soften it and condition the collagen fibers. And the last step is pickling. So pickling is done just before the tanning process. So in the tanning process, some color will be added to the dye. So to ensure that the tanning process is done effectively, we have to make sure that a lot of salt is added. So that's what happens in the pickling process. So salt will be added, and the skin will be allowed to be in the salt water for some time, so that the tanning process becomes efficient. Then coming to the tanning process. So there are two types of tanning. The first one is chrome tanning. So chrome tanning is done using trivalent chromium or chromium 3 plus. So the chromium 3 plus solution will be prepared, and the skin will be allowed to soak in that solution for about 24 hours, and then it will be taken for bleaching. So instead of this, we can also do vegetable tanning. So vegetable tanning is an alternative where some natural tannins in the bark and leaves will be collected from trees, and then that will be used for tanning instead of chromium. Second step is bleaching. So during the tanning process, because we are adding chromium salts, the animal skin will become blue. So to remove that, we have to add some bleaching agents, and that's what we do in the bleaching step. So once the blue color is removed, along with that, all the chromium will also come out. So the bleaching step will produce a lot of chromium containing wastewater. The next step is ringing. So ringing is usually when you put clothes to dry, we wring them, right? We turn them and we squeeze them to remove excess water. So that's what we do with animal hide also. So we wring it and we remove the excess moisture. And the next step is splitting. So splitting involves dividing the animal skin into two parts, into two layers actually. So the top layer, it has some grains, and the bottom layer is that is used for making like a different type of leather called suede leather. So yeah, these two layers can be separated. So this is done because the tanning process will be inefficient otherwise. So that's why we are breaking it into two different layers. And then the last step is retanning. So the tanning process is repeated again. So like we can go for either chrome tanning or vegetable tanning, and this is done to increase the durability of the leather. And then coloring. So based on what color leather we want, we can add coloring agents. And this is about the tanning process. So the next step is finishing. So in finishing, we add fats. So this is fat liquoring. That's the first step in the finishing process. So here we add oil or grease or even crude oil, and then the skin is staked and buffed. So this is done to induce some greasiness or oiliness into the leather. Okay, so this is about the process that happens in the tanning industry. Now let's come to the wastewater that is generated in all these processes. So the wastewater coming from a tanning industry can be divided into two parts based on the flow. So the first one is intermittent wastewater, and the second one is continuous wastewater. So intermittent, as the name suggests, it comes in some intervals. So maybe once in 1 hour or maybe once in 3 hours, and then it stops and then comes back again. So that is intermittent flow. So certain processes like soaking or liming, pickling, tanning, all these processes generate intermittent wastewater. And this intermittent wastewater is highly concentrated. It contains high amounts of salts and BOD, and compared to continuous, it has a higher concentration. Whereas the continuous wastewater that is generated comes from processes like washing, flushing, hair removal, and the continuous wastewater that is generated it has lesser concentration. So in general, the wastewater that comes from the tanning industry contains sodium, salts, chromium salts, oils, sugars, and acids. Okay, now let's look at specific wastewater from different processes. The first one is spent soak liquor. So the spent soak liquor is the wastewater that comes from the soaking process. So it contains a high level of salts, because this is one of the first steps that we do as soon as we get the hide. So it contains a lot of salts because salt is added, and it also has a lot of dirt and soluble proteins. And because it comes directly from the raw hide, so and this is the first step that is performed on the raw hide. So dead animal skin can contain a lot of bacteria. So this water will also contain the same bacteria, and it is prone to bacterial growth. So it already has bacteria, and it also has organics that bacteria need to break down. So this wastewater will support bacterial growth. And then the second one is spent lime liquor. So this is a wastewater that is collected in the liming process. So like I said, liming is done for removing the hair follicles, and that is what the wastewater that comes from that liming process is highly alkaline. So, and it also has high amounts of ammoniacal nitrogen and sulfides. So it has high alkalinity. Ammoniacal nitrogen and sulfides. Then comes spent vegetable tanning liquor. So this is the, I mean, we get this only when we go for vegetable tanning, not for chrome tanning. So this, the water that wastewater that comes from the vegetable tanning has extremely high COD. Okay, so what is COD? What is COD? You can even type your answers. So COD means chemical oxygen demand. And this is the amount of oxygen which is required to chemically oxidize the organics present in the wastewater. And also, spent vegetable tanning liquor has very low BOD to COD ratio. So what this means is the amount of biochemical oxygen demand is lesser compared to the chemical oxygen demand. So that means it tells about the nature of the organics that are present inside this wastewater. They cannot be degraded easily by bacteria, and they need to be chemically oxidized using oxidizing agents. So that's what this means, and this cannot be taken for biological treatment process. Okay, coming to chrome tanning waste. So the chrome tanning waste, as the name suggests, it's the wastewater that we get after the chrome tanning process. So this wastewater contains high levels of chromium salts. And also it must be segregated from other types of wastewater. Reason being that once we segregate, we can remove the chromium, we can precipitate the chromium salt as chromium hydroxide, and once we precipitate it, we can even recover the chromium as a solution. So this chromium solution can be reused in the process. So that is why we have to segregate the chrome containing waste. For recovery, so that we can recover whatever chromium was there as precipitate, and then we can convert it into a solution. So then we can reuse that chromium again for the process. So this reduces the cost of the process. We don't need to buy more chromium, and it also reduces the environmental burden. So in every batch, significant amount of chromium is generated. So instead of wasting it, we are just reusing the same amount of chromium, and the recovery is about 90%. So 90% of the chromium that we use initially can be recovered, and that's a good number. But there are some challenges in the treatment of tannery wastewater. First one being that the tannery wastewater is high in organic loads. Reason being that since it is basically animal skin, which contains fats, proteins, and even bacteria, so all this will contribute to a lot of organic load. And also, we are basically removing the hair follicles, and we are basically deconstructing the skin. So while that process goes on, the skin will also lose some of its proteins, which are like organic, so which will contribute to organic load. So naturally, this process generates wastewater which is high in organics. And the second one is that the process generates wastewater having a high solids content. Meaning that both suspended as well as dissolved solids are higher in tanning wastewater. And the third challenge is use of presence of highly toxic salts. So, like we just saw, salts of chromium are used. So, chromium is a carcinogen. So, that's why the wastewater that we get from this industry contains a lot of chromium salt, which is highly toxic. Let's look at the treatment process now. So, the first type of treatment is physical. And the first step in the physical treatment process is screening. So, screening, like you would have already seen, involves removing any floating objects using a fine mesh screen. So, there are two types of screens, coarse and fine. Both are used for removing any floating objects. So, that is the first step. Second step is primary sedimentation. So, in primary sedimentation, about 95% of the chromium is removed. So, this involves precipitation, coagulation, and precipitation. So, in this process, about 95% of the chromium salts can be removed as sludge. And the third step is chemical treatment using coagulants. Okay, so this is about the physical treatment or the primary treatment. Then comes the biological treatment. So biological treatment involves processes like activated sludge process, anaerobic contact filters, anaerobic lagoons, Upflow anaerobic sludge blanket with extended aeration. So following this, we have the tertiary treatment. So this includes processes like membrane filtration, reverse osmosis, ion exchange, and adsorption. So we've already seen all these processes, so I'm not going into detail. Like this was a general treatment process, but we also need to look at how to remove chromium. So, like I previously said, for chromium removal, 95% of the chromium gets removed in the sedimentation itself during primary sedimentation. But the problem with primary sedimentation is we are sedimenting it as sludge, and after that, the sludge may have some impurities also. So, recovery of pure chromium and chromium salt from that process is difficult. So, this is especially true when we don't have segregated chromium waste. So, if we can segregate the chromium waste, that is separating the chromium containing wastewater separately, and then we are going for this precipitation, coagulation, etc. So then we get sludge which only has chromium, and from that the sludge can be treated with concentrated sulfuric acid. So this will react with the chromium containing sludge and it will produce chromium sulfate. So this is in the form of a solution. So this chromium sulfate that is generated, it will be in solution. And the solution can be reused for the next batch. So that's the advantage of chromium recovery. So other options that we have are evaporation, but evaporation will leave behind residues containing chromium, but the chromium containing residue will not be purely chromium, it will have other impurities also. So that is why that process is not preferred. And the chromium containing spent liquor that we get from this, it can be reused. So that is the advantage of precipitating and then segregating, precipitating, and then reacting it with sulfuric acid. Okay, next, this is all about the tanning industry. The second industry that you must have seen in this week's lecture is the paper industry, paper and pulp industry. Okay, so same question. What do we get from this industry? What do we get from the paper and pulp industry? What are the products from the paper and pulp industry? It's a very basic question, right? So, paper and pulp industry, the raw material is just pulp or wood pulp, and we process the wood pulp, and the final product is paper. So, the paper and the process, depending on the process in the paper industry, the industry can be divided into two parts. Uh, like the industry can be divided into two categories. The first one is integrated mills, and the second one is separated mills. So in integrated mills, we have both the pulping operation as well as paper making. So these two processes happen in the same industry or in the same mill. So that is why it is called an integrated mill. So before we make paper, we have to take out the pulp. So that is the pulping operation. And during the pulping operation, we separate cellulose from the wood. So the pulping operation means separating cellulose from wood. And the second process is actual paper making from the leftover fibers. So if these two processes are taking place in the same unit, then it is called an integrated mill. Okay, once we remove the pulp, then the final step is to bleach with chlorine or hydrogen peroxide. So this is done to make it white in color. So generally the wood pulp is slightly brownish, but if we want to get white paper, then we have to add some bleaching agents. Okay, first let's look at the pulping process. So the pulping process can be mechanical, chemical, or a combination, which is chemomechanical. So mechanical means beating the pulp and using mechanical processes. Since beating is a mechanical process, that's why it's called a mechanical pulping. And then comes chemical pulping using chemical agents to remove the cellulose, and then a combination of chemical as well as mechanical processes. So in this chemical process, an important type of process is the Kraft process. So in this process generates a kind of wastewater called black liquor. And in the combination process, chemomechanical, first we add some chemical agents as pre-treatment, and then we go for mechanical refining. So that's why it's a combination. And during the Kraft process, some harmful substances like dimethyl sulfide and methyl mercaptan are released. So both these substances are hazardous in nature. So that is one drawback of the Kraft process. And once we separate the cellulose, The next step involves washing the fibers. So this is about pulping. The second one is the paper making process. So once we have separated the cellulose, then the fibers are to be washed. And the wastewater that comes from this process contains a lot of suspended solids. Dirt, grit, and fibers. And the wastewater that comes from the digester house generally contains volatile organics like methanol, acetone, and chloroform. And also this wastewater also contains high level of nutrients. So if there are nutrients like phosphorus, nitrogen, potassium, then that will help in overgrowth of plants, which is called eutrophication. So have you heard of this term called eutrophication? What is eutrophication? What is eutrophication? So eutrophication is where if there are excess nutrients, then and the excess nutrient containing water or wastewater is supplied to lakes, then the plants in the lake tend to overgrow, and as they overgrow, they use up all the oxygen, available oxygen, and then that creates an anoxic environment, which is not good for the survival of fishes and planktons. So ultimately, the fishes die and the plants keep on growing. So that's eutrophication. And the wastewater that comes from the tanning industry is high in nutrients, so that's why it cannot be disposed of directly, because that could lead to eutrophication. So whatever nutrients are there, they need to be removed first. Okay, so now coming to the treatment process. The first step is recovery. Then we have physical, chemical, and biological processes. Okay, so are you getting any scratching sound while I write? Is that like, does that create a lot of sound? Does it interfere with my voice? Are you able to hear me clearly? Is my voice audible? Yeah, so that creates a sound, right? So is that interfering with what I'm saying? Okay, I think there is some issue, but I'll try to rectify it. Okay, so the first step of the treatment process is recovery. So recovery is usually done to reuse within the same batch for production. Um, like for example, we recover lignin and lime. So this is done so that we don't need to buy lignin and lime over and over again. So they can just be reused after recovering it. Then we do chemical treatment to remove color. So what this chemical treatment involves is basically coagulation and flocculation. So is the sound or noise better now? So are you still hearing it or is it gone? I don't see any response. Okay, so since this process involves adding lime, so that is why we need to reduce the pH. So that is done using decarbonation. And to also stabilize the treated water after lime addition. So since we cannot continue the treatment process if the pH is so high, so that's why we need to reduce the pH by adding carbon dioxide. So that will create carbonic acid, which will automatically bring back this pH to normal range. So once this is done, the wastewater is sent to a secondary clarifier to remove any remaining sludge. And we can also use processes like dissolved air flotation. So dissolved air flotation is used for removing very fine particles which cannot settle down. So what we do in this is just, create some air bubbles. So the air bubbles will carry the fine particles to the top and then they can be just skimmed off. So this is done when we have very fine particles. And then coming to the biological treatment processes, we have waste stabilization ponds. So this can be used if we have sufficient land available. So if there is a large amount of land next to the paper and pulp industry, then we can go for waste stabilization pond. So this is just like a pond where we put all the waste and then allow the bacteria to grow. So since it is done in an open air, so we don't even have to aerate the pond. And then we have aerated lagoons. So aerated lagoons are similar to these ponds, but the difference here is that the aeration is done mechanically. So external air supply is provided. So and because of that, the efficiency is better. So if the efficiency is more, then the retention time will be reduced. So in a smaller time, we can in a shorter amount of time we can oxidize the organics in the wastewater. So that is why aerated lagoons have higher efficiency. And this is used when the influent or the wastewater BOD is moderate. So it should not be very high because since this is not uh, like as efficient as activated sludge process or trickling filter process, it's just like a pond where or a lagoon where we just allow the wastewater to stagnate and then we aerate it, and during that process the bacteria will degrade the organics present. So this is not highly efficient, so that's why this process can be used only for uh, wastewater containing a moderate level of BOD, not very high BOD. Or it can be used as a final polishing step. Once we go for the ASP or activated sludge, or maybe even some anaerobic process, after that, whatever wastewater is left, that can be brought for aerated lagoons as a final polishing step. And if we want to go for biological treatment, then we have to keep in mind that the BOD is to nitrogen is to phosphorus ratio should be 100 is to 5 is to 1. And if the wastewater does not contain BOD, nitrogen, or phosphorus in this ratio, then we can add urea, ammonia, or phosphorus or phosphoric acid. So this can be added to ensure the ratio is this. Okay, coming to anaerobic processes, like aerated lagoons, we also have anaerobic lagoons. Now this is for combined mill effluents. Like if we have an integrated mill and we are getting a combined effluent, then we can go for anaerobic lagoon. But like I said previously, after this anaerobic lagoon, whatever wastewater is left, that should be taken for aerobic treatment because that will still have some organics which can only be broken down by aerobic bacteria. So we can, like I said, we can go for aerated lagoon after the anaerobic process. But usually for aerobic processes, we use ASP or activated sludge process. And this is all about secondary treatment. Then we can even go for processes like ozonation, photocatalysis, and even membrane processes. So all of these come under the category of advanced treatments. So advanced treatments offer high efficiency, but at the same time they are expensive. So That's why we only have to use them when necessary, and we cannot use them. And also they require certain amount of pre-treatment also. So yeah. So once we get the treated effluent, that can be sent for land treatment or for irrigation. But if we go for any of these, we still have to ensure that the regulatory norms are followed. So there are certain norms for small as well as big paper industries. So they differ. So the land application norms require that the BOD be within a certain range, the salt content or the solids content be within a certain range. So all that comes under the norms. So these norms are different for smaller industries and bigger industries. So each of them have separate norms. So yeah, that's about the paper and pulp industry. So now we will be looking at the some of the processes that we saw in detail. Um, so when we talk about waste stabilization ponds, so these are cheaper, and if there is a large area of land available, then this is a very good method. And because it requires very low capital investment, so it is also a cheaper process. And it also ensures that the BOD removal is at least or a minimum of 85% of BOD is removed. So that's the advantage of having a waste stabilization pond. So, and the depth of these waste stabilization ponds are usually between 0.9 to 1.5 meters. On the other hand, aerated lagoons they provide higher efficiency, but like we need to have aerators, and we cannot use diffused aeration here because diffused aeration could lead to pore blocks. So diffused aerator is different from a mechanical aerator. So in a mechanical aerator, aeration is done using a stirring or a mixing process or just by turbulence. So because we have a stirring action, so this propels the water upwards towards the surface. So imagine this is the surface of water, and we have a stirrer which is continuously like stirring. So this sometimes will propel the water layer up, or like it could form some bubbles, or this could lead to uh, the mixing of or the dissolving of oxygen into the wastewater. But on the other hand, a diffused aerator is something like this. So imagine this is the water level. So if we have a diffused aerator, so that will be like so from here air bubbles are introduced through small tiny pores. So this is a diffused aerator. So here the aeration is created by mechanical action. But here we provide aeration from the inside the surface of the liquid, under the surface of the liquid. So that's the difference between the two. So here diffusion directly happens here, but in the first case, diffusion happens after aeration. I mean after mechanical mixing. Okay. So that's the difference between the two. So, in aerated lagoons, because of the high solids content from the paper industry, we cannot use it. We cannot go for diffusion or diffused air aerators, because then the pores could get blocked from the solids, and yeah, in such cases, mechanical aerators are better. So in aerated lagoons, the influent BOD is moderate. It cannot be very high. So that's why it can also be used as a polishing treatment. So aerated lagoon can also be used as a polishing treatment. Polishing treatment means like it is the final treatment before discharge, just to ensure that the treatment efficiencies, the BOD removal is slightly increased. So this is the final, this can be used as a final treatment process after the main treatment process is done. So similar to aerated lagoons, when we talk about ASP or activated sludge process, so here also mechanical aerator or mechanical aeration works better than diffused aeration. So again, for the same reason, that is pore blockage. And if we are going for ASP for the treatment of paper wastewater, then we have to keep in mind that sometimes there could be some fine fibers. So from the paper industry wastewater, so these fine fibers are non-biodegradable. And also, if we go for ASP, we have to ensure that there should be a settling tank. And if there are fine fibers, then these fibers do not settle down quickly. So, yeah, that's the disadvantage of using ASP for the paper wastewater treatment. And also, talking about other aerobic processes like maybe trickling filter. So Trickling filter is not, that is also not very widely used for paper wastewater because, again, trickling filter is basically attached growth process where we have um, some media on which the bacteria is allowed to grow and wastewater is allowed to percolate or pass through it. So again, we have the same issue here. So the pores could get easily clogged because we have some fine fibers. So and because the solids content is also high, so this could lead to pore clogging and you know the fibers could get uh, stuck between the pores. So that would lead to uh, poor efficiency or poor removal. So yeah, and trickling filter can only get you about 40 to 50% of BOD removal. So in a typical treatment process for pulp and sorry pulp and paper wastewater, the following steps are used. So the first one being lime treatment. The second one is using a clarifier. The third one is using a cooling tower. And right after cooling tower, we have to add nutrients. Nutrient addition is done to maintain CNP ratio, carbon, nitrogen, phosphorus ratio. So in order to maintain this, if there is deficiency of nitrogen or phosphorus, then external addition is required. The next process is anaerobic lagoon. So we've already seen anaerobic lagoon, so I'm not going to discuss it. And this is followed by aerated lagoon. So always anaerobic lagoon is followed by aerobic lagoon. And sometimes the waste from paper and pulp industry can also be mixed with other wastes, and together they may be treated in the following sequence. So first there is grit chamber, followed by clarifier, stabilization tank, finally by aerated lagoon. So, in the case of some small mills, like there are like small mills, then they may not have a separate treatment process for black liquor. So, in those cases, the black liquor is stored separately in lagoons. So these are stored there, and they are allowed to, you know, for allowed for biodegradation, so that they can avoid separate treatment. So these are the typical treatment processes. So the first one being lime treatment. This is followed by clarification and then cooling tower. And then if there is any nutrient deficiency, then that is added in order to maintain CNP ratio, a good CNP ratio. So here we've seen, yeah. So it should be in the range of 100 is to 5 is to 1. So it is the BOD is to nitrogen is to phosphorus ratio. And then it is taken to an anaerobic lagoon, and that is followed by aerated lagoon. So this is a typical treatment process. But sometimes we can also go for land treatment. So land treatment is allowing the waste to be absorbed by the soil. So it is like the waste is simply uh, disposed, or it is allowed to stagnate on the soil. So then what happens is the soil tends to absorb some of the pollutants on its surface. So by this action, we get cleaner water. I mean, relatively cleaner water. But the absorption or the kind of pollutant that is absorbed, that entirely depends on the cation exchange capacity, or CEC. So CEC is a typical characteristic of soil. So depending on the type of pollutant and the cation exchange capacity of the soil, uh, only then if we know these two only, we can say if the pollutant can be absorbed by the soil or not. So depending on the cation exchange capacity and the type of pollutant, the level of absorption could vary. So for some pollutants it could be quite high, for some pollutants it could be very less. So sometimes the treated effluent can also be used for irrigation. Now, this serves two purposes. One, it uses the wastewater, treated effluent, and on the other hand, it also reduces the water requirement. So, this is a very good application. So, if the treatment efficiency is very good, so after following the tertiary treatment as well as polishing steps, we can apply the treated effluent in irrigation fields. And usually, for the treatment of pulp and paper wastewater, a combination of two or more so a combination of two or more physico-chemical processes ensures high removal. So, like we saw the various types of physico-chemical processes like adsorption, ion exchange, yeah, adsorption, ion exchange, or even coagulation, flocculation. So, like a combination of two or more of PCPs can ensure high removal. And also, even if we combine physico-chemical processes with biological treatment, even then we can achieve higher removal if there's a combination of physico-chemical with biological, like what we saw here. So having a clarifier and then followed it by anaerobic and aerated lagoons. So this is a example of how the physico-chemical as well as biological process can be combined. So in series. So that's all for this lecture. Thank you.